This is a comprehensive problem from Chapter 9, a schedule of expected cash collections and disbursements. Calgon Products is a distributor of organic beverages that needs a cash budget for September. The following information is available. The beginning cash balance as of September is $9,000. Actual sales for July and August are expected, and expected sales for September are listed below. Sales on account are collected over a 3-month period as follows: 10% in the month, 70% in the following month, and 18%. The remaining 2% is considered uncollectible. The purchase of inventory will be $25,000 for September. 20% of the month inventory purchases are paid for at the time of purchase. The accounts payable remaining from August purchases are $16,000, all of which will be paid in September. Selling and admin's budget is $13,000 for September. Of this amount, $4,000 is depreciation. Equipment costs will be costing $18,000 will be purchased for cash during September, and dividends totaling $3,000 will be paid during the month. The company maintains a minimum cash balance of $5,000. An open credit line is available for the company's bank to bolster their cash needed. Prepare a schedule of cash collections. Prepare a schedule of cash disbursements for inventory purchases in September. So, here are cash sales, sales on an account, and total sales for the month. So let's put down what information we do have. Cash collection is 10%, and this is in month. Cash collection in following month. Fix this so we can read it. All right. Is 70%, and then cash collection in second following month, 18%. We have purchase inventory of in September of 25,000. Um, 20% of the month inventory purchases are paid in the month that you purchase them. Paid in month following the purchase. All we're doing is putting down given information. We knew AP in August will be 16,000. We'll purchase equipment for cash in September for 18,000. Selling and admin expense is 13,000. Depreciation was 4,000. So the cash selling and admin expense is actually the difference of these. And then the company has minimum cash balance of 5,000. Okay. So the very first thing that we should do, we should start with September's cash sales. And then September's cash collections on account. So we have July sales, and this would be the second month following. So we take July sales on account, and we multiply by the second month following number, which is 18%. Then we take August sales, and August sales on account was 30,000, and month following is that. And then we would take September sales, and so September sales are 40,000, and we're in the same month, so we collect 10% of those. So total cash collections. We add these all together. So in September, we would have $36,000 of cash collections. Now, number 2 says payment to suppliers. So we must figure out what in September we would pay for August purchases on AP, and that was $16,000. September purchases, and we had $25,000 in September, and we pay 20% of that in the month that we're in, paid and purchase month. So we multiply those two numbers. So total cash payments to suppliers equals the sum of these two. $21,000. Now, in order to have a cash budget, number 3, cash budget, Calgon products for month ending September. All right. Okay, so we start with the beginning cash balance. And they told us in the problem the beginning cash balance is $9,000. Then we add cash receipts, collection from customers. So we're going to collect $36,000 from customers. Total cash available before financing. Then we have payments to suppliers. Well, actually, let's call this less cash disbursements. Payment to suppliers, which was $21,000. Selling and admin expense. We're going to take only the cash number, remember, because we're working with cash. Equipment purchase. dividends paid. We forgot to put this in the given information. And we also forgot to put starting cash balance. There's a lot of information in this one. So my dividends paid. Dividends paid equals $3,000. Total cash disbursements is $51,000. So excess or deficiency of cash available. We take what we had before financing, subtract our expenses, and we have a negative amount. So financing, borrowing, we need to have a $5,000 cash balance. So we need $6,000 to be at zero plus our minimum cash balance, which was $5,000. We need to borrow $11,000. We're not repaying anything. We haven't been charged interest yet. We will. Total financing equals the sum of this. Cash balance September 30th. We take our negatives and we add our financing, and we should have $5,000. This is our minimum required cash balance. So this is a cash budget. Now that we've done a production budget and a cash collections budget in the previous video, we are going to move on to a direct materials budget from Chapter 9. This is exercise 9-3. Microproducts, Inc. has developed a very powerful electronic calculator. Each calculator requires 3 small, quote-unquote, chips that cost $2 each and are purchased from an overseas supplier. Microproducts has prepared a production schedule budget for the calculators by quarter for year 2 and for the first quarter of year 3. The chip is used in the production of the calculator is sometimes hard to get, so it's necessary to carry large inventories as a precaution against stockouts. For this reason, inventory of the chips at the end of the quarter must equal 20% of the following quarter's needs. A total of 336,000 chips will be on hand to start the first quarter of year 2. Required, prepare a direct materials budget by quarter and in total for year 2. At the bottom of your budget, show the dollar amount of the purchases for each quarter. Okay. So, given information. Required ending inventory, 20% of next quarter's budget. Beginning inventory, this is the information given in the problem, 36,000 units. Okay, so I'm just going to copy the time frame here, and we are going to make a direct materials budget. Okay. So we start with required production. And we got this number from up top. It was given in the book. So required production is 60,000 for the first quarter, 90,000 for the second, 150,000 for the third, 100,000 for the fourth, and 80,000 for the first of year 3. Now, in order to understand how many chips we actually need, these are units being produced, number of chips per calculator. Okay, it told us in the problem that they produce a very powerful calculator. Each calculator requires 3 small chips. So every unit is going to need 3 chips. So I'm going to multiply the number of units by chips, with 3 chips. So we need 60,000 units, and each of those needs 3 chips. So I need a total for the first quarter of 180,000 units. I'm just going to drag my formula over so that all of these are multiplied by 3. So this is my production needs. Here's my direct materials budget for year 2. I'm going to copy my quarters here. Okay. Production needs for chips. This is the number we just calculated up here. And to calculate the total for the year, we're just going to add all of these up. So we need a total of 1,200,000 chips. Plus, we need to add desired ending inventory. And remember, they told us that desired ending inventory was 20% of next quarter's budget. So in the first quarter, it would be 20% of the second quarter budget. In the second quarter, it would be 20% of third quarter budget. In the third quarter, it would be 20% of fourth quarter budget. In the fourth quarter, it would be 20% of the first quarter budget for year 3. And our desired ending inventory for the year would be quarter 4, 48,000. So now we must calculate the total need for chips. We're going to add these two together, our production needs plus our ending inventory needs. And I'm just going to drag my formula across. So what this is saying is we need 234,000 chips in the first quarter, 360 in the second quarter, 510 in the third quarter, 348 in the fourth, and a total of 1,248,000 for the year. But remember, we start with some sort of inventory. So we need to subtract beginning inventory for chips. Now, in the problem, they told us that we would start in July, in the first quarter, with 36,000 chips on hand. In second quarter, our beginning is our first quarter ending. Third quarter, second quarter ending. Fourth quarter, third quarter ending. And our beginning inventory for the whole year would be our beginning inventory on first quarter. So once we subtract this, we have required purchases of chips. Okay, so we take our total needs, subtract beginning inventory. And these are how many chips we need to purchase for the year. Now we know that the cost to purchase is $2 per chip. All I'm going to do is take the number of chips we have to purchase and multiply by $2. And this is a dollar figure. So this is how much we're going to have to spend on direct materials per month, per quarter, I'm sorry. And I'm going to drag my formula across, assuming I can grab it. So this year, we will spend $2,424,000 purchasing chips. This is a direct materials budget. Now, I understand that this was not assigned as homework, but I'm going to go over it because it's the only remaining missing budget that we have here. Exercise 9-4 is a direct labor budget. So now we've done cash collections, production, direct material, and now we need direct labor. So the production manager of Junin Corporation has submitted the following forecast for units to be produced each quarter for the upcoming fiscal year. Each unit requires 0.4 direct labor hours, and direct labor hours workers are paid $11 per hour. Number 1, construct a company's direct labor budget for the upcoming fiscal year, and assume direct labor workforce is adjusted each quarter to match the number of units required to be produced in the forecast. 2, construct the company's direct labor budget for the upcoming year, assuming direct labor is not adjusted. Instead, assume that the company's workforce consists of permanent employees who are guaranteed to be paid 1,800 hours of work each quarter. If this number of required direct labor hours is less than this number, the workers are paid anyway. If it's in excess, they are paid 1.5 times the direct labor rate. Okay. So let's kind of put this down. So these are the units to be produced. Direct labor hours is 0.4, and direct labor price per hour is $11. So let's start with number 1. Let's assume that direct labor matches what is required to be produced. So we start in calculating the direct labor budget. Units to be produced. And this is given in the problem. Then we have the total. We just add all of these units up. Okay. Then direct labor time per unit. And this is 0.4 hours. And in order to make this remain the same, because I'm going to use the 0.4 across the whole board, I just hit F4. Then I drag this across. So now we're going to come up with total direct labor hours needed. This is how many hours needed to produce this number of products. We multiply units to be produced by the direct labor per unit. Then I'm just going to literally drag my formula across. Direct labor cost per hour. Remember, this is $11 per hour. It was given in the problem. Again, I'm going to go back to my item and hit F4 so that it knows to keep the $11 per hour across the whole, each quarter. So total direct labor cost. We take the units, labor hours needed, multiplied by the $11 because we're only going to work the hours we need. And then we're going to drag this across. So we have a direct labor cost this year of $82,720. Number 2 says, well, it's not that easy. We can't just match every hour because these people are guaranteed some sort of work. So what do we do then? So let's copy this here. So we're going to have the first quarter. We're going to start with the units that need to be produced, right? And that's not going to change. Okay. And then it's also not going to change the time needed. It's really only going to change cost. Hours needed per unit. And it's 0.4. Remember, and we hit F4 to drag that across the whole way. So far, setup is the same. So now this is the total direct labor hours needed. And we multiply. Units times the required hours. Okay. At this point, we have the number of hours. Now, we have regular hours. They said that the regular hours are 1,800. So I'm literally going to just type that in and drag it across. And the required for the year would be the sum of this 1,800. Okay. Now, we take this and we calculate overtime hours needed. Well, anything over 1,800 hours is overtime. If it's less, we're just going to put a 0. If they require less hours than 1,800, we put a 0. This one's even. This one has more than 1,800, so calculate how many overtime. And our total overtime for the year is the sum. Even though we work less hours than required, certain months work more than the 1,800 hours. So then we calculate wages for regular hours. This equals $11, and I'm going to hit F4, times the 1,800 regular hours. And every month has 1,800 regular hours. And I'm going to just add this across. Now we calculate wages for overtime, 1.5. So we take this and we take our $11 and we multiply by 1.5, and then we multiply this by the overtime needed. And I forgot to hit F4 on my formula, so I'm going to go back, hit it, and then drag my formula again. And then I'm going to add up my overtime hour wages. Now, this is our total direct labor costs. We're going to add these two columns together. Add wages and overtime wages together. So if we compare this, we would need 85,140 if we guaranteed hours instead of 82,720 for direct labor. Now I'm going to save this, and I'll do the problem 9-16 separately in a different video.